يعطيكم العافية. نبلش second lecture من ال Communication Electronics. In this slide we will briefly talk about modulation techniques. We will start with introduction about modulation and why it is important. Then we will talk about analog modulation, which is amplitude modulation and phase modulation, as well as frequency modulation. Then we will go through digital modulation and bandwidth concentration. In previous lecture, we spoke about time domain. So time domain is the signals changing with the time. We have the variable time, such as the speech signal. Also, we spoke about the frequency domain. As you know, sometimes it is very important to transform the time domain to frequency domain to be mathematically easy to handle. Signals may be represented by frequency domain, and the variable here will be f, or frequency. In previous lectures, we spoke about negative frequency. All signals have this negative frequency components as well. It's called the image, and a sinusoidal is often called a single tone because it has one frequency, but also plus the image. Decibel, it's very important to handle the decibel and understanding how to convert to decibel and dealing with the number in decibel, because in the communication system almost all the data sheet coming with decibel value. In previous lecture also we spoke about power in dBm. Due to simplicity in calculation, we like to express power in logarithmic scales. Power is not a ratio, so how can we do this? As I told you, calculate the ratio of the power to 1 milliwatt and express that in dB. We call this dBm. So as these equations, it represented the power in dBm. For calculating the power, often power dBm is used between parts and audio system to describe signal propagation. We are not measuring the power in our design itself, but we are assuming that the signal is connected to a virtual resistance 50 ohm resistor, and we are measuring the power. dBm can be used at interfaces that do not necessarily entail power transfer. Now let us start with an introduction about modulation techniques. Need for modulation. Why we need modulation? Every channel has a cutoff frequency, so theoretically signals with frequency less than cutoff frequency cannot propagate through the channel. There may also be a lower frequency limit, such as a human voice is limited to 4K Hz. Normally it is less than cutoff frequency. This problem also cannot be solved by amplification, so we need modulation. This slide represents the electromagnetic spectrum. It is a good idea to look at it thoroughly. What is modulation? Modulation is carrying the information signal on the radio frequency signal. It is a process of mixing a signal with a sinusoidal to produce a new signal. Mixing of low frequency signal with high frequency carrier is called modulation. We do that to allow us to send a signal over a bandpass frequency range, or another reason to modulate a signal is to allow the use of a smaller antenna. We use modulation to turning information into electrical signal which are suitable for transmission. So we use modulation in a transmitter side, and we use demodulation at receiver side. Modulation types. The signal properties are varied according to the information. So properties of any RF signal, it has amplitude, frequency, or phase. These are variables. So this variation could be continuous or could be represented as discrete step, such as digital modulation. Modulation aspects, it is just some elements we have to take in account when we choose what modulation we're gonna use. Detectability, the first one, it is very important because detectability for binary, like the first image here, it is 101, which is in fact sending cosine, then sending nothing, then sending cosine, and so on. This is what we call two-level system or binary system. The second image is represented the four-level signal, which is sending 0 1, then sending 1 0 and 1 1, then 0 0, which is relies on the amplitude, which is four-level signals. In the four-level signals we can send more information, it's obvious, but it is not immune for or less immune to noise. Okay, but the detectability for the binary, it's much more easy for detectability in four level signals and so on. Also, we have another aspects like bandwidth and power efficiency. Bandwidth and power efficiency in communication is very important because it costs money. Then we will also we need to understand the complexity of this modulation before we choose to work on it. The required bandwidth for this modulation, sensitivity to noise, how much it's sensitive to noise and sensitive to nonlinear, etc. Next, we will briefly review analog modulation, such as amplitude modulation. Amplitude modulation, I believe most of you guys know what's amplitude modulation: multiplication of a baseband signal with a single tone sinusoidal called the carrier. So we have modulated signals, we have the carrier, we multiplication these two signals to come up with amplitude modulation. It's very important to study the amplitude modulation in frequency domain. Actually, if we have a signal cosine WCT, converted to frequency domain, it is one frequency domain. Then the message itself will be convolution in frequency domain. As you know, if we have multiplication in time domain, we will use the convolution between two in frequency domain. So 0 will be shifted to the carrier frequency, as you see. So we have two copy of the message at carrier frequency. Multiplier or the mixer, it is just multiplying two signals in the time domain. From this perspective, mixer can occur in any nonlinear device such as diode or transistor. So when we say two signals just multiply to each other, we have down converted component and up converted components, as you see in the slide. AM variants of AM modulation are double sideband suppressed carrier, or single sideband. The main problem in the AM modulation is the higher bandwidth and wasted some power, or more power is needed than other modulation. Now, for phase and frequency modulation, in the most general form of RF signal can be represented as S of t equal A cosine phi of t. Phi of t is called total phase. Now, instantaneous frequency is defined as the derivative of phase angle. In this respect, phase and frequency modulation are essentially the same, except for an integration. As you see in the slides, there is two equations, the first one and the second one, for FM and phase modulation. Typical FM and phase modulation waveforms is represented in this slide. Note that amplitude is constant, so it's more immune to noise than AM. Data is contained in zero crossing intervals. The modulated signal has theoretically infinite bandwidth. Digital modulation, it is the same as analog modulation, but we have now dealing with not continuous waveform, it is discrete waveform. So this slide represented two images. The first image is given analog amplitude modulation. Then the second one is digital, which is amplitude shift keying. Digital modulation is more immune to noise because it can work with a smaller SNR, signal to noise ratio. We have three types of modulation in digital modulation as well as in analog modulation. We have amplitude shift gain ASK, PSK phase shift gain, and frequency shift gain.